Yeah, let's just go outside.
All right, so we've done the starter question yet, right? Let's review completing the square.
Okay.
Isolate the non-variable.
Okay, so we're gonna do what first?
Subtract one.
Minus 1.
Where is this at?
So we get 2x squared plus 5x equals negative 1. Now what's our next step?
5/2 and then
Divide by 2, right? Let's go divide by 2. We're going one at a time here, Josh. Don't go crazy on me here. So we get x squared plus 5/2x. And I'm going to leave a space here equals negative 1/2. Now we... All right, Josh, now it's time. Now we do what? So now we got to take 5/2 and half it and square it. So what's half of 5/2? 5/4, good. And we write that down, remember, because we're going to need it later. And what's 5/4 squared? 25/16. Add that to both sides.
Did I give you the project?
Okay, so what's 1/2 with a denominator of 16?
what did you just?
What's 1/2 with a denominator of 16? What over 16 is equal to 1/2? 8/16, right? So I get 25 minus 8 is, right, and I'm looking right here, 25 minus 8 is 17/16. And now this mess is a perfect square trinomial, and it is x plus 5/4 squared. Okay, that's why we write that 5/4 down.
Negative
So now we're going to do what? Square root both sides. So we get x plus 5/4. Oh, gosh. Equals plus or minus root 17/4. Correct? Because the square root of 16 is 4. You okay? Now we minus 5/4. So we get x equals negative 5 plus or minus root 17 all over 4. Okay. All right, not too bad. Okay. So including all this, we've probably done about 20 problems by completing the square. So hopefully at this point we're pretty darn good at it. Okay. Now, process is exactly the same for each one. Numbers are going to be a little different. Got to do a few different things, you know. Might have to divide by something or whatever. But then we get some nasty fractions. But you guys can handle these pretty well right now. I'm thinking, okay. I mean, that's a pretty tough completing the square problem. You guys just nailed it. Okay, that was good. All right. So now when mathematicians run into processes like this, they usually solve the problem in general to make a formula. So that's what we're going to do now. Okay, so we're going to take the general form of a quadratic, ax squared plus bx plus c equals 0, and I'm going to solve this for x. Okay, and I'm going to do it by completing the square. Okay, so now this part, okay, if you guys get a little bit lost throughout this process, don't stress it. Okay, it's all right. All right, just wanted to, we're just basically what we're doing now is deriving the quadratic formula. Okay. Okay, so again, so now the exact same, we're going to use the exact same steps we just did. So we're going to minus c from both sides here, and then divide by a. Okay, so if we minus c, we get ax squared plus bx equals negative c. Okay, and then we divide by a, so we get x squared plus b over a, really? Yeah, it was b over a, then I'm right the x there. So b over a x equals negative c over a. Okay? Now we're ready to complete the square. So we take half of b over a, which is, and write this down, b over 2a. Okay? Right, 1/2 times b over a is b over 2a. Okay, now we're going to square that. So that becomes b squared over 4a squared. I'm going to go plus b squared over 4a squared. Okay? Now, on the right side, we've got to get a common denominator. So what's that common denominator going to be? 4a squared, right? Okay. So now, I'm going to write that b squared first. And then we've got minus here. Now to make this 4a squared, I got to times it top and bottom by 4a, right? By 4a. So I times the bottom by 4a, the top by 4a. So now I get minus 4ac. Okay? And then that's all over 4a squared. Okay. Now, let's write this is a perfect square trinomial on the left. Now let's come back to the left. Okay, you're going to write that as a perfect square trinomial. So that mess is x plus b over 2a quantity squared. Messy as that is, it does make a perfect square. Okay? Next step, square root both sides. Okay, so we get x plus b over 2a equals the square root of, well, plus or minus, the square root of b squared minus 4ac. Now what's the square root of 4a squared? 2a. Good. And now we subtract 2a from both, b over 2a. So we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Hey, isn't there like one of those like songs and
Yes, we did it last year in class, Emma. What's the song that we do it with?
Jack in the Box, I think.
Well, yeah, but that's also Pop Goes the Weasel. So, yes, Gertie, you're right. Pop Goes the Weasel, right? Anybody care to sing it?
I have no idea what's going on, Mr. Price.
What do you mean you have no idea what's going on?
Kind of lost me at the part where you get the common denominator with the, it was just so,
I know, that's fine. It doesn't matter. This is what you need to know.
Something.
but that's the.
That's the quadratic formula. Yep.
A.
There we
Did we
go.
learn that, or,
Yeah, we did.
but should we now?
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, you should know that. You learned it last year.
And does it always have the?
That's not a bad melody.
You know. Okay, now this is called the quadratic formula. All right, so let's formally write it here. So again, x equals negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. Okay. Now, that is a formula you will have to have memorized. Hence the song, right? We remember songs much better than we do just stuff.
Can we sing the song like 10 times?
You can do that on your own, please.
I forgot it already.
Just remember Pop Goes the Weasel, Josh. Don't complicate this. All right, now, the important thing about the quadratic formula, okay, is that you identify A, B, and C correctly, okay? Now, in order to do this, okay, you have to have everything on the same side with the 0 on the other side, and then it has to be written in descending order, okay? If it's not written in descending order, write it in descending order. If everything's not on the same side, get it on the same side. And the nice thing with the quadratic formula, it doesn't matter which side. Just throw everything on one side and then identify A, B, and C, and then you plug and chug. Okay? That's all there is to it. So, with that being said, let's do a couple. Okay, so in this case now, let's look at A here. So so let's identify, first of all, is everything on the same side? Yeah, is it in descending order? Yeah. So let's identify A, B, and C now. So A is, what's A here? A is 2. What's B? Positive 5. And C is positive 1. Okay. Now let's plug it into your quadratic formula. So x equals negative b plus or minus the square root of 5 squared, which is 25, minus 4 times a, which is 2, times c, which is 1. We really don't have to write that down, but we will. All over 2 times a. Okay? Now let's simplify. Okay? So we get 4. So now we're going to go underneath the square root first. So what's 4 times 2 times 1? 8. And 25 minus 8 is? Say 17. All over 4. Done. Now look at your starter problem. No, it's the same problem.
Oh, my gosh.
And how about our answers? Amazingly, they are the
That is so
same.
much easier than what the heck you guys did at the beginning.
Okay? Now, like I said last time, there is a time and place for completing the square. Okay? Problems like this are not one of those times and places. Okay? Quadratic formula, as you just learned right there, and you just stated, light years easier. Okay?
Maybe learn later, like, what works best for what.
Yeah, I mean, it's just kind of like if you're given a perfect square, completing the square, you can use square roots, that's probably easier. But yeah, we'll kind of go over that a little bit as to what type of problems work best and which ones don't,
What if you
okay?
get the wrong one every time?
It doesn't matter. Even if you do the wrong method, if you do it right, you'll always get the same answer.
Yeah, what if you did the hard method every time?
Well, then good on you, as long as you get the right answer, I don't care, okay? Yes?
So if b is a negative number, will that first number right there be positive?
Yes, it will. Excellent question. Did everybody understand that question? If b starts out to be negative, then that negative b makes it positive.
Okay.
Okay.
All right, so part B here, what's the first thing we have to do?
Get all the numbers.
Get everything on the same side and put it in descending order. So we're going to minus 3, and then we're going to write in descending order. So we get 5x squared plus 8x minus 3 equals 0. Now we're ready. X equals negative b plus or minus the square root. And what's 8 squared? B squared minus 4 times a, which is 5, times c, which is negative 3. Don't forget to keep that negative going. All over 2a. Okay, let's do some simplifying here. So 4 times 5 times 3, what is that? Let's see, 4 times 5 is 20, times 3 is 60. Now is that 60 a plus or a minus?
It'll be a plus.
It's going to be a plus because I got 2 negatives there, right? So I have 64 plus 60 is
164, 124.
124. Good.
You need to say your answer's louder, you're always right.
All over 10. Okay, now, can we simplify 124? Yeah, most likely, huh? So what does 124 break down into?
Probably something with a 4 in it.
Probably 2 and 62.
2 and 62.
Let's keep going. What does 62 break down into?
31 and 2.
31. So now I have, so 124 is 4 times 31, correct? Okay, what's the square root of 4? 2. Let's take that out.
I was right, did I say 4 and something?
So now we get, yes you did, Gertie. 2 root 31 all over 10. Now what can I do? Reduce it by a 2, correct. So that gives us negative 4 plus or minus 1 root 31 all over 5. And there we go. There's your final answer, okay? Now, on tests, you're going to be given quadratics and asked to solve them, okay? And we've talked about a lot of different ways. We've talked about factoring, okay, which is far and away the easiest. But obviously, like in this case, all quadratics aren't factorable, okay? We can use square roots if we've got a perfect square. You just square root it and go. We can complete the square. And now we can use the quadratic formula, okay? Here's the nice thing about the quadratic formula. It always works. 100% of the time. If it's factorable, the quadratic formula is gonna work out nice and clean for you. Perfect squares, doesn't matter. Quadratic formula will always, 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 always work. Okay? So if you're ever not sure, plug in that quadratic formula and go.
Did you say always a lot? It sounds like always.
But now, okay, the key is the underline there, though. Always use the method that is requested. Okay, you need to get good at all of them. You need to be good at completing the square. You need to be good at factoring. You need to be good at using square roots, and you need to be good at using the quadratic formula. Okay, so make sure you always use that method. Okay, so let's talk again about methods for solving quadratics. All right, if there's a perfect square, isolate it and then take the square root. That's the square root method, right? So if you've got a perfect square in there, that's the easiest way to do it. Okay? If there's not a perfect square, write the equation in standard form, which is ax squared plus bx plus c. Write it in standard form, and then factor it if you can. Again, factoring is always easy. Okay, if neither one of those work easily, then you can use it, solve it using the quadratic formula. Okay?
Standard form, just a simple.
Standard form, yeah, it's ax squared plus bx plus c. Okay? All right, so x squared minus 5x minus 4. All right, is there a perfect square in there? Is that a perfect square?
No.
It's not, so the first thing we want to do is try and factor it. Will that factor, just off the top of your head? Can you see that? Okay, minus 4, what's minus 4 going to break down into? 2 and 2 or 4 and 1. But with the minus, what do we know about our signs? Signs are opposite. So can I break that down and get negative 5 out of it? I can't. So it's not factorable. So now let's look at the quadratic formula. Okay, now is completing the square an option here? It's an option, but when I take half of negative 5, what do I get? A fraction. Ugh. Don't do it. Okay? If that middle term is odd and you know you're going to get a fraction out of the deal, do not complete the square. If it's even, completing the square would be an option. But if it's not, don't. And plus it's set up already for the quadratic formula. Okay, so let's plug in the quadratic formula. Okay? So we get, hang on. Okay, so we've already determined on this one now that we're going to use a quadratic formula. So we get x equals negative b, and like Emma said, because it's negative, it starts negative, we change it to positive, plus or minus the square root of negative 5 squared, which is 25, minus 4 times a, which is 1, I'm not even going to write that down, times c, which is negative 4, all over 2a. And again, a is 1, so I'm not going to write it down. Okay? All right, negative 4 times negative 4 is 16. 25 and 16 is? 25 plus, it's a plus, right? 25 plus 16 is? 41. Done. Move on. Okay, so our example here, first step.
Factor out 3.
Okay, we could do that, or we could. Okay, divided by 9 is going to give me some yucky fractions. How about we add 25? Okay, so we get 9x squared plus 30x plus 25 equals 0. Okay, so now we want to try and factor or use a quadratic formula.
Factor.
Okay, let's see if this will factor. 9x squared, what does that break down into? 3x and 3x. Tell me about my signs. Signs are the same and they're both positive. 25, 5 and 5. Does that work? Do my outers and inners add up to be 30? Yes, they do. So in this case, this one's the easiest to factor. And what's my answer? Remember how to do that quickly? Negative 5 over 3, right? Subtract 5, divide by 3. And since both binomials are the same, I can do that. So there's your answer right there. So again, factoring definitely the easiest. Now, what if I didn't know that and I plugged it into the quadratic formula? What am I going to get? I better get the exact same thing, right?
Where'd the negative come
Because I subtract, if 3x plus 5 is 0, I'm going to minus 5 and divide by 3. Correct?
from? Yeah.
So if, because it's 3x plus 5 twice, so if 3x plus 5 equals 0, I subtract 5, 3x equals negative 5, then divide by 3. Okay. All right, now, let's do the quadratic formula on this. I know there's some big numbers, so I'm going to need your help, but I just want to show you. So we get x, so we're going to use this one right here, obviously. So x equals negative 30 plus or minus the square root of 30 squared, which is 900, minus 4 times a, which is 9, times c, which is 25, all over 2a. 2 times 9, which is 18. Okay, 4 times 9 times 25 is amazingly going to be 900. So what's 900 minus 900? 0. Hey, we are left with negative 30 over 18. What goes into 30 and 18? Somebody say 6. Thank you. So I get negative 5 over 3. We'll all be darned. Same answer. So again, doesn't matter. You're going to get the same answer either way. Okay, number 8 here now. We do not want to divide by 3 because that's going to give us fractions all over the place. So let's check and see if we can factor it. Because this is an easy check. All right, 3x and x. 2 and 1, signs are the same, they're both negative. Okay, well, can I put 2 and 1 in here to get 7 out of my outers and inners? Everybody say yes. If I put a 2 here and a 1 here, right, what do my outers and inners add up to be? Minus 6x minus 1x is minus 7x. Hey, we're good. So what does x equal now? Equals 2 and add 1, divide by 3, people. 1/3. Thank you. Okay. Now, if I did quadratic formula, or if I did completing the square, I'd get the exact same thing.
How would you get 2 answers?
Because I got 2 answers. I got 3x minus, you mean the quadratic formula? Because it's plus or minus,
Oh, okay.
right?
Mm-hmm.
Okay. Okay, number 12 here, we minus 1. Now, is this one going to factor for us? Yeah, there's no way I'm with ones all over the place. I'm going to get 4 out of my outers and inners. So we're going to go straight to the quadratic formula. Now, this one would definitely be a completing the square candidate, right? If we left it in its original form, half of 4 is 2, squared is 4, so I add 4 to both sides, and then I can square root it and go that way. That's actually fair. That's probably easier than quadratic formula. Okay? So if the first term is 1 and the middle term is even, you really want to consider completing the square. But you don't have to. Quadratic formula always works. But let me just show you real fast the completing the square. So let's erase this, okay, because we just need it in this form. Now we're going to do the quadratic formula as well because that's what the section is. We got to try it. So we go half of 4 is 2. 2 squared is 4. We add that to both sides. Then on the left we get t plus 2 squared equals 5. And now we square root both sides. So we get t plus 2 equals plus or minus root 5. And then we subtract 2. So t equals negative 2 plus or minus root 5. There's completing the square. Pretty easy. So if it's not factorable and your first term's 1, your second term's even, consider completing the square. It's not too bad. Now let's show you the quadratic formula. Okay? So we got to minus that 1. So again, we get t squared plus 4t minus 1. So we get x equals negative b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is negative 1, all over 2a. All right, so under our square root, negative 4 times negative 1 is positive 4. 16 and 4 is 20, so I get negative 4 plus or minus root 20 all over 2. What does root 20 break down into? 4 and 5. Square root of 4 is 2, so it's 2 root 5. So I get negative 4 plus or minus 2 root 5 all over 2. Now I can reduce everything by a 2. So what do I end up with?
Negative 4 plus or minus root 5.
Negative 2 plus or minus root 5. Got to reduce that 4 by a 2 as well, right?
Do you kind of just want to do every one twice?
Okay. Now again, on that one, if you like that quadratic formula, do it that way. Okay, completing the square is a little quicker, but, you know, if you don't like completing the square, which most people don't, I'm not a fan, but I've done this enough now that I can identify when it's gonna be easier than quadratic formula. Do the quadratic, but I'll always do the quadratic formula. Okay. Okay, so on this one now, all right, yeah, definitely quadratic formula. Completing the square is gonna give us fractions. We don't wanna mess with that, so we're just gonna go straight to the quadratic. So x equals -1 plus or minus the square root of 1 squared minus 4 times a, which is 1, times c, which is 4, all over 2a. So 4 times 4 is 16. 1 minus 16 is -15. We don't like square roots of negative numbers, so what are we going to do? Take our eye out. Good. You're never going to be rid of them, Gertie. Never, never, never. And there's your final answer.
No, I'm just sad that you took my eye out.
And, you know. That's how we roll here, Gertie. All right, best method to use this example.
The one where you factor it.
Okay, yeah, well, except that doesn't factor though, right? X squared plus 9. If it were x squared minus 9, we'd be all over it. But we can't factor.
Bigger, so I can see what the problem was.
Oh. That sucks.
Okay, so the quadratic formula would work here, but it's easiest just to do this. Oops. Remember, if we have a perfect square, isolate that perfect square. And now we can square root both sides. What's the square root of -9? Not I root 3. It's I root 9, which is
3i.
3i. There you go. Okay. Now again, quadratic formula would give you the exact same answer. All right, what's the first step here? Yeah, distribute you've got to distribute, right? And then we get everything on the same side. So here we get 5x squared minus 5x minus 7. And here we get 4x squared minus 8x. So we're going to minus 4x and add 8x, so 4x squared, sorry. So 5x squared minus 4x squared is x squared. We're going to add 8x. Negative 5x plus 8x is plus 3x minus 7. Now, does that factor? What do you think? Okay, can 7 break down to give us 3?
No.
Can't, can it? So, is this a decent candidate for completing the square? Nah, middle term's negative or is odd. So, quadratic formula. -3 plus or minus the square root. 3 squared is 9. Minus 4 times a, which is 1, times c, which is -7, all over 2a. All right, -4 times -7 is positive 28. 9 and 28 is 37. Is that right? All over 2. Okay, can't simplify 37. We're done. It's as good as we can do. Okay. You know what, normally I would, but Slick loves problems like this on finals. Okay. So, what do we have to do here? What's our first step? Get rid of our denominators, right? So we're going to times everything by x times x plus 4, right? Got to be both of them. So x times x plus 4 over here. What happens with this first 7? Yeah, the x's are going to cancel. Right, so I got 7 times x plus 4. Now what's going to cancel on this last one? The x plus 4s are going to cancel, so I'm left with
7x.
just 7x. So now I get x squared plus 4x equals 7x plus 28. Oh my goodness. I totally missed that one. Plus 28,
Where did the x squared come from?
right there, plus 7x. The x times x plus 4 gives me x squared plus 4x. Okay. All right, so let's see, we got 7x and 7x, so we're going to minus 14x and minus 28. So we get x squared minus 10x, 4 minus 14 is minus 10, minus 28 equals 0. Does that factor? 28, 14 and 2, 7 and 4. So close. But I don't think it does. So, complete the square. Decent candidate for completing the square. Or we can quadratic formula. What do you want to do? Want to complete the square or quadratic formula?
Quadratic.
Quadratic? Okay. Let's do it. So x equals negative 10,
It's fine.
Positive.
or the opposite of negative 10, plus or minus the square root of negative 10 squared, which is 100, minus 4, times a, which is 1, times c, which is negative 28, all over 2. I would have definitely liked to complete the square on that one. Okay, 4 times 28. 132?
112.
112, I mean? Yeah, sorry. You gotta add it. Duh. So 112 plus 100
212.
is 212. See, now we gotta break down 212. I'm thinking 4. 4 goes into 21 5 times with 1 left over, 53. 4 times 53, square root of 4? 2, so we get 10 plus or minus 2 root 53 all over 2. Cancel the 2 out, so we get 5 plus or minus root 53. Okay? Now, can I just show you completing the square real quick, how easy that one's going to be on this one? So if I add 28, I get x squared minus 10x equals 28. Half of 10? 5 squared. So now we get x minus 5 squared equals 53. Square root both sides. We get x minus 5 is plus or minus root 53, and then we add 5. So again, if the situation's right, completing the square really is pretty easy. But again, I leave it up to you. If you're good with the quadratic formula, go to your happy place, right?